Hello everyone, I am at Arizona State University's Photovoltaic Reliability Lab, and I'm here with Dr. Manny, and we're going to talk about solar panels and their performance and reliability. What can you tell me about that?
Good. Thanks for this opportunity. So here in this laboratory, we are working on two levels. One is on the performance level, and the other one is on the reliability level. So the difference between performance and reliability, I can put it in a simple way that the PV module works on the first day. Will it work next 25 after 25 years? So the performance is about the performance of the solar panel on the day 1, and if that performance is maintained over next 25 years, then that is related to reliability. So in this lab, we are working on both performance and reliability. So the performance is affected by basically two factors. One is the irradiance, and the second one is the temperature. And so higher the irradiance, higher the performance, and higher the temperature, lower the performance. So now if you take New York and for example Arizona, we have lots of sunshine, and New York has a less amount of sunshine, about 30% less amount of sunshine. But in New York, the temperature is lower and we have a higher temperature. So in winter time, if you assume the same amount of sunlight in New York, you will have a higher power output, but less amount of sunlight available over the year. So if you take quantitatively about 30% more sunlight here, and but we have a higher temperature. So our performance will go down by about 10% because of the higher temperature, but we have 30% more sunlight as compared to New York. So yeah, Arizona is the one of the best places for solar panels. That is about the performance. Now yes, let us say that we have a solar panel of 300 watts, and the day 1 it is a 300 watt on a bright sunny day, cool bright sunny day, and now it has to work for next 25 years. How it is the performance is going to be affected, or the lifetime is going to be affected due to the field conditions. In the field, basically there are three factors can affect the lifetime. One is the extent of ultraviolet light, the second one is the temperature, and the third one is the humidity. These three can affect. If you have a higher ultraviolet light, the solar panel which you have a glass, and you have a solar cell between the glass and solar cell there is a polymer layer, it is called encapsulant. That encapsulant can become brown, and that means the transmittance will be reduced. Once the transmittance is reduced, the power is going to drop. So that is a one major degradation mode in solar panels.
So you're saying that ultraviolet light causes this to get a brown coating,
right,
and then that will affect how well the solar panel performs.
Right, that is right, because it is going to cut the transmittance, which means it is going to cut the current, which means it is going to cut the power. So that is one major degradation mode for the solar panel, determining the lifetime. So in this lab, what we do, since it is a lifetime prediction reliability laboratory, we have a different equipment to test this susceptibility to these factors. So first one is UV. UV is a major degradation mode, degradation influencing factor. So we have a UV chamber here, that you can see the UV chamber, and here these are all the UV lights. And if you look at sunlight, 5% of sunlight is UV light. That is why we have skin cancer and other things. It is because of the UV light presence. And that 5% over 25 years, you can think of that can break down some of the polymeric materials which are existing between the glass and the cell. And once it becomes brown, as I said before, it can drop the things. So here we are having a 5 sun. So, we have only one sun outside, we have 5 sun here, and it works 24 hours a day. And that one works only daytime, but this one works 24 hours a day. So, we accelerate, we compress 25 years of lifetime in about 6 to 8 months.
Oh, wow.
So, we compress that. So, we have such a high UV dose in this. And so, you can see the solar panel. This is a solar panel which we have there, and so now we can put large number of solar panels this side and this side, and we expose it, and we expose it about 6 months. That will be equivalent to about 25 years in the lifetime in the field.
Wow, so you actually put all these solar panels in there,
Right.
close it up, and then turn it on for 6 months.
Yeah, we leave it inside for cook it for 6 months.
Wow, and then you open it up and see what the results are.
Yeah, right, right.
Yeah.
We take it out every few weeks to find out how much it is degrading over time. So just to check the performance over time. But yes, it needs about 6 months exposure, at least 6 months exposure.
And so performance, so basically solar panels can be used anywhere in the world, but you have to take into consideration those 3 factors,
Right.
UV, humidity, and temperature fluctuation.
That's correct. That's correct.